Hi. Hi.
Fernando.
Nice talk. Yeah, nice talk. Actually, I like the topic. I enjoy the topic, and actually, we were in my research group. We were thinking of integrating into Windows also seismic dissipation. So other kinds of metamaterials, kind of seismic, not conventionally defined, but new types of seismic metamaterials that can dissipate energy in during earthquakes. So this is another possibility of this interesting research, and I believe that windows are indeed important components of next generation buildings. So it would be nice to also explore the possibility of an integration of this other feature in your nice windows.
Yes, thank you so much for your comment, Professor Paternali. Actually, yes, this multi-physical approach it needs to be implemented. So basically what we want to do from now to go on is to implement the system as much as possible to make it applicable to real built environment system and to real building features. So this is a sort of ongoing projects that of course is a layering of different testing, different characteristics and different functionality of the window, and definitely the structural part and the seismic part could be a core part of it.
Thank you.
Thank you, Fernando. Related to your question, I was wondering, Gioia, if does your model with, with this concept of controlling at the same time noise and ventilation can be used to add the other parts of the envelope of the building? I mean, not only for window, but some other structural or non-structural components of the envelope of the building. If you thought about.
Yes, I think basically, so this methodology can be, so first of all, this methodology, I believe, can be applied to most of the building features design. So it can apply to, could be applied to, for example, we have applied it to window, but it can apply to lateral, like vertical and horizontal division, or structural systems, as Professor Fraternali was saying, or for example, to just furniture, really, like any sort of building feature that is involved within the indoor comfort and the indoor well-being and human perception of the indoor environment. However, definitely, this can be, and this is so at more small scale, if you want to say so. If we think about bigger scale, such as, for example, barriers or any sort of massive structures that nowadays are characterizing skyscraper, or let's say much bigger systems rather than a simple window, I believe this methodology can be perhaps extended and can be scaled up to that dimension, since of course the most important thing is to keep track of the multiphysical evaluation and the ergonomic impact of this system over human perception. So I believe I haven't tested yet on bigger scale, let's say, but I think, and I am confident that this methodology can be applied also to bigger structures, definitely.
And also another feature, yes, if I can ask another question, I'm sorry if
sure,
I'm asking too much. Another feature is about the solar, the energy harvesting, solar energy. So this is another important feature in the future. So this is another topic. So I believe that windows are important components of buildings. So I think that in your project you can add additional features, and that is really important for different purposes. So also, because we need to arrest energy, renewable energies, and the buildings usually are taller than larger than wider, and so the facades of the buildings are important to arrest energy, are really important, because usually we have for example, we in the buildings the solar panels or photovoltaic for PV panels are placed on the roof, but this is the surface available on roofs is not as large as that available on facades. So also for energy harvesting, and indeed you can also harvest wind energy, integrating some components in the window. So I think this topic is really interesting. So congratulations for the choice of the topic.
Thank you so much. Yeah, so because my background is like building engineering and architecture, but I have been lucky to being involved into both more social science based and more, let's say, for example, physics based studies. So I have a sort of overview which is as general as possible within these different fields. So social science field, natural science and prototyping industries, industrial systems. So I think that the contribute right now could really impact the applicability of metamaterials if we apply it in a smart way to all different sort of tasks and of challenges that right now are open due to energetic requirement or to structural requirement as well.
Yes, indeed. Also for reducing pollution, environmental pollution. So yeah, many variants, many possibilities.
Yeah, the difficult task I think right now is because metamaterials are not very users are not very familiar with metamaterial at the moment. Probably most of the population don't know the existence of it. So the important task right now, I think the challenge is to make it more, as I was saying, make it more available to the broader public, if we want to say so, in order to make them aware that there is another solution, and so to create a sort of place within the market for this new kind of material to be used. Probably it's not something, that's not an easy task. I'm confident of it. I mean, I know this is something, probably that's something that will be realized, if possible, in 10, 20, 30 years from now. But I think that, you know, like this is innovation, so we have to stick to it.
Yeah, this is very true.
Then you even mentioned furniture, and we can think about maybe more about integrating metamaterials in design and even to the arts part, because at the end metamaterials start on with a sculpture, the idea, I mean. And we should go back to this idea to implement more in the design and the artistic part of the building.
Regarding design, is there Oliver connected? Oliver is connected?
No, I didn't saw him. Yeah.
Because I have this nice lamp just arrived from Oliver.
Oh, that's nice.
So Oliver does some. Yeah, this is about design.
In Paris.
Kind of. So I have this.
Very nice.
Just arrived from Oliver from Japan.
Great.
Very nice. Yes,
okay, please, Gioia.
No, yeah, I think that right now, so as we were saying, it's not that metamaterials have been discovered at all. Like we have a basic knowledge of what metamaterials can do. So I think right now the interesting challenge is to deploy them for different functions and different, like they are very versatile materials, as very versatile systems if we study them and if we develop them accurately, tuning them to different frequency ranges. So why not? Also, I think the non-dependency on the constituent material especially creates a very wide range of application, also in terms of more artistics, if you want to say so. Because of course, I know that today we are not speaking about physics much, or we are not speaking about very important things that we have done so far in these webinars, but we are speaking more about the applicability of it and the ergonomicity of it, and how to make it more accessible to the broader public. So why not? Definitely architectural and artistic installation can also be implemented through acoustic metamaterials.
But it is important to contribute to the diffusion and the technological engineering applications of metamaterials. Yes.
And maybe reaching the point to mix even more of this application. I mean, with kind of panels have noise, ventilation, light control, or
light control, energy harvesting, and and also, you know, for example, for thermal insulation, there is another feature, metamaterial feature, that can be which is related to the Knudsen effect. So the fact that if you have a porosity at the nanoscale, or you can trap, you can block due to the sides of the voids in the material. So with the nanoscale printers, 3D printers, you can create materials or windows that have a thermal insulation properties derived by geometry, by the fact that you have a porosity at the scale such that the heat cannot pass through, is trapped into the material. So no, I think it's you can experiment many things, and not only noise, isolation, but also in earthquakes, the windows are important. It is important to dissipate energy in the windows, in the windows frames, and are elements that can collapse. So yeah.
Okay, that's great. Many ideas. And do you have any other questions from the public? If not, let's thanks Gioia again, and great talk, and see you all next week. Stay safe. Thanks.
Thank you so much.
Bye.
Bye.
Thank you. Bye, everybody. Bye, everybody.